Okay, so first one. Good morning. Okay, Margo is walking in a straight line from a point 30 feet due east of a statue in a park toward a point 24 feet due north of the statue. And so we don't really care that it's a statue. What we care about is that she is starting right here at 30, 0, and she is ending right here at 0, 24. Does that make sense?
Yes.
Yes? Okay, write parametric equations for Margo's positions t seconds after she starts walking. So we have one point which is at t equals 0. Her location is 30, 0. So we go to our general formulas here. X equals a plus bt, and y equals c plus bt. And if we plug in that stuff, what do we figure out? A is 30, and c is what? 0. Okay? All right, you understand how that happened? Yeah? Okay, what happens next? Find the distance. We need to find out how far she walked from here to here. Okay? So this is a right triangle with one leg of 30 and another leg of 24. So the distance is going to equal the square root of 30 squared plus 24 squared, which is 38 point what? 38.41, let's go for 2 feet. Okay? So if she is traveling 38.42 feet and she is traveling at a rate of 4 feet per second, how long does it take her to travel that distance? Eh? 9.6. 205? 05. I'm good with 9.6. So let's go with 9.6 seconds. So what that has done is that's given us another data point, essentially, which is when t equals 9.6, her position is 0.24, right? So now we can take this general equation right here and substitute in there 0 for x. We now know that a is 30, t is 9.6, and we can solve that for b. And what do you get? For b. Negative 3.12. All right? And then same thing with the y over here to figure out what b is. We can substitute 24 in there for y, 0 in there for c, and 9.6 for t. And what do you get when you solve that for b? 3 point what? 2.5? 2.5-ish. All right, so that means our equations, parametric equations for her position are x equals 30 minus 3.12 t, and y equals approximately 2.5 t. Okay? So I had 2 people participating fairly regularly in that process. Any of the other 18 kids that didn't say anything have any questions about what just happened in your life? Anthony? This distance right here, we use that to figure out at what time she ended up at this point right here. Because to do the parametric equations, you not only need a location, but you need a time. So we knew that she started 30 feet east of the statue, so that's at time t equals 0. And we knew that she ended up 24 feet north of the statue, but we didn't know what time she got there. And we needed to know that in order to plug it in for t to solve for b and d. Okay? So we took that and divided it by her rate, and then we were good. All right, awesome. Any other questions? No? Okay? All right, so next one, write an expression for the distance from Margot's position to the statue at time t. Anybody got that?
I'm not sure.
You have no idea? Got nothing? Okay, well, we're basically finding the distance between 2 points still. The difference is the 2 points, one of them is changing, okay? So the statue is at, we decided 0, 0, okay? What is her location at any time? Yeah, the parametric equation. So her position at any time t, x is 30 minus 3.12 t, and then her y position is 3.5 t, 2.5 t. Right? So we just use those in the distance formula just like you regularly would. So you say the distance between 2 points is the square root of x2 minus x1, which is just this, but we would square it, plus y2 minus y1, but we would square it. Okay? So that gives our distance from the origin at any time in t. That works for me, yeah. I thought about maybe having some fun and foiling it out and simplifying. What? Because it's, you know, the distance formula, so it's the Pythagorean theorem.
Oh.
So, okay, so it's a squared plus b squared, and we take the square root. All right, so you okay with that?
Yeah.
Okay, so that's really not so bad once you know what you're trying to work with there. Okay, find the times when Margo is 28 feet from the statue. So we can take that other formula that we just figured out, which was 30 minus 3.2 t 1 squared, 3.12, plus 2.5 t squared. And notice this is in parentheses, so the 2.5 is going to be squared also. Okay, the whole thing is squared. And we want to set that equal to 28. And it says times, because there could be more than one. I don't know if there is or not, but if you think about a circle with a radius of 28, that is not a circle. If you think of a circle with a radius of 28, that circle, it's not if it's got a radius of 28, huh? Because this is 24, so it's only going to intersect at one place. I thought the circle might like come in here and then come back there, but that's not going to work. So I think we're only going to get one answer. So hopefully someone will check our work. So what's the easy way to do this? What's that? Oh, because she keeps walking as she goes past the statue. Okay, so Brandon, clearly the smartest man in this class, says that there's 2 of them because there's going to be one right here, but she's going to continue to walk past here, and there's going to be another one right there. Okay, so you're going to end up with 2. So what's the easy way to solve this? You want to square both sides? Well, we're going to need to.
Okay, well, let's do it.
Okay, let's do it. So 30 minus 3.12 t squared plus 2.5 t squared equals, what's 28 squared? 784. Okay, then we need to FOIL this out, right? So 30 times 30 is 900. And then for me to get the middle term, do you know how to do that when you're squaring a binomial? Yeah, 2ab, so multiply these together and then double it. So that's going to be 90-ish doubled is how much? $187.24. Just 2. And that's going to be t plus 3.12 squared is 9.74. t squared, okay, good, plus 2.5 squared t, 2.5 squared is 6.25, t squared equals 784. Okay, so now we have this delicious quadratic. How do we solve a quadratic equation? Yeah, we're going to do the whole quadratic formula thing.
I can help you with this real quick. If you do the exact values, the t squared is not exactly 16.
So what?
If you do the exact values, the t squared is exactly 16.
Oh, when these add up together, they make
Yeah.
exactly 16 if we did not round. So this should be 16t squared, okay? Minus 187.2t plus, you subtract those, you get 126 equals 0. Okay, is that what you came up with?
I just use the calculator.
You use the calculator, yeah, right. I know, you can use the calculator, you can graph it and all that kind of stuff, but it'd be good for us to practice the quadratic formula, just for fun. Okay, so the quadratic formula goes like how? Opposite of b, so 187.2 plus or minus the square root of b squared. What's that squared? Emily, can you give me a calculator from
187 squared.
Yeah, well, thank you. 187.2 squared. Should we do that by hand also?
35,004.82.
Okay, so that's b squared minus 4 times a times c, yes? 4 times 16 times 126, 8,064. Then you take that total and you divide it by 2a. All right, so if we figure out the stuff underneath the square root, 35043.84 minus 8064 equals, and then take the square root of that. So we get 187.2 plus or minus 164.26 divided by 2, right? Divided by 32, that's what I said. There's no recording that will prove that that's wrong. All right, so you add those together, divide by 32, and then subtract them and divide by 32, and tell me your two answers. $187.2 plus 164.26 divided by 2 is, divided by 32 is what?
10.98 is a plus one.
Okay, 10.98 is the plus 1, so that would be the second time that she crosses that she is 28 feet away from the statue. What's the first one when you subtract and divide by 2?
0.717.
0.717, Hannah? 717, yeah. Okay, which again, if you look back at your drawing to check reasonableness, it does appear, I mean, I have my circle kind of, I didn't make a very clear sketch here, that circle's not centered, but it does appear that she would cross that circle pretty quickly, and then take her a long time for that to happen again. So that seems like those are two relatively reasonable answers. Okay? All right, so we good with that? We're good. All right, next one, Juliet and Mercutio, which we all know from Romeo and Juliet, are moving at constant speeds in the XY plane. They start moving at the same time. All right, so let's get a little more serious here with our illustrations. So I have to get to negative 14 on the Y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's going to be close. But we will give it a try. All right, Juliet starts at the point 0, negative 6. So 1, 2, 3, 4, 5, 6. Here is Juliet at 0, negative 6, at time t equals 0. All of that is important. It heads in a straight line towards the point 10, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. And Juliet goes that way. Whoops, she's going backwards. Juliet. Hello, Miranda.
Are you wearing pink?
Am I?
Yeah.
No, I don't own any pink. I'm sorry.
Is there anywhere in you'd wear pink that did?
That looks good right there? Okay, it says, oh, she reaches it in 10 seconds. Woo, that's good, Jamie. Mercutio starts at 9, -14, so 1.
Hey, what's your passcode?
Jack. So this is where he is.
How long is it?
Huh?
How long are your password?
Nifty. And then it says, Mercutio passes through the same point on the x-axis as Juliet, but 2 seconds after she does. So he's going on this path right here, but he gets there 2 seconds after Juliet. All right? How long does it take Mercutio to reach the y-axis? Oh, we've got some serious work to do here, don't we? Okay. What do you want to do first? Figure out Juliet's parametric equations? Okay. So, do you understand, without us doing the math, that if Juliet starts at 0, -6, in these two general forms of the parametric equations, what they're saying is that A is 0 and C is -6. Do you see that? Because that's going to give you your starting point in each direction at time t equals 0. Okay? So I'm going to just kind of, well, I guess I'll write that down. So A is 0, C is -6. So now we're going to use those two things plus this point here to figure out what B is, right? So I'm going to say 10 equals, A is 0, B times the time, which is 10. So B equals what? 1. Okay, so her equation of motion in the x direction is very simple. It's x equals t. So that's nice. Then if I use the y coordinate there, 5 equals -6 plus b times 10. Add 6 to both sides, you get 11. 11 divided by 10 is 1.1. So b is 1.1, which means her equation for motion in the y direction will be y equals -6 plus 1.1 t. Okay? And hopefully you guys can all do that on your own. All right, what are we going to do with those?
We're going to put it under
Find out where she crosses the x-axis.
Find out where she crosses the x-axis. How do we do that? What's that? Y equals 0. Okay, so when y equals 0, that is at -6 plus 1.1 t. So if I add 6 to both sides and divide by 1.1, that happens at the time what? 5.45 repeated. Okay? Well, no, it's 4545. It's 5/11ths. Okay, so if she crosses the x-axis at the time 5.45 seconds, where does she cross the x-axis? I meant to say if she crosses the x-axis at 5.45 seconds, where does she cross it? At 5.45. Because the x's and the times for her are the same, okay? So the point of interest right there is 5.4, I'm going to stop with the repeating thing, comma, 0, okay? She gets there at 5.45 seconds, so when does Mercutio get there? 7.5 seconds. 7.45. Okay? So now we have his initial starting point and time. We have another point for him that we know that he gets here after 7.45 seconds. And so we can do the same thing with him that we did with Juliet to come up with his equations, right?
Yeah.
And then if we want to find out how long it takes him to get to the y-axis, what do we do for that? Set x equal to 0. Okay, so I'm thinking if you're Brandon and you're wanting to do it the most lazy, efficient way that you can, do we need a equation for his y motion, or can we just do the x part? You did them both just because that's how you roll? Okay. Do you want to do those? Why do you do those on your own? And then we'll check them. All right, so you should come up with those equations. And again, all I've got going here is I've taken this one right here, x equals a plus bt, and I'm substituting 5.45 for the x. What did we figure out a is? The x coordinate of their original starting point, so 9. So 5.45 equals 9 plus b times 7.45 seconds. So subtract those, divide by 7.45, and you get this. And you should be able to kind of, I mean, again, there's some checks to do along the way. This came out to be negative because their motion in the x direction is going in the negative direction. So that should come out to be negative, okay? And then same thing for the y, and you get that. All right, so how long does it take them to reach the y-axis? What do I do?
Plug in 0 for x.
Plug in 0 for x, because the x coordinates are all 0 on the y-axis. So then if I go 9 divided by 0.477, you get about 18.87 seconds. Is anybody checking our work, see if we're doing this right?
18.92 meter rounded.
Okay, yeah, right. So we were rounding as we went. Okay. All right. So, whoo, there's a lot going on in that problem. Okay. That was a handful.
I don't like it.
What's that? Yeah, that's good. I mean, if you came in and looked at this and went, oh yeah, totally awesome, then we kind of wonder about you. What? Jeff doesn't like this. He's good at it. It comes more naturally to him.
No, you know, last year he did like 6 weeks of homework because he said he was bored and had nothing else to do.
Well, that's a different issue. All right, and then the last two are just some little algebra ones that we've been reviewing periodically as we have made our way through. What do we need to do with this to solve for x? Nope. What do you have to do with fractions? Common denominator. What is my common denominator going to be?
X squared plus x.
Okay, right. X squared plus x. I'm going to leave it, undistributed. So I have to multiply this x by the x plus 1 to get this denominator, which means I have to multiply the numerator by the same thing. So x plus 1 times 1 is x plus 1 minus, I had to multiply this denominator by x to get this, so I have to multiply the numerator by the same thing. So x times 1 is x, and that equals 3, right? Sure. So on the top, the x's cancel. So I get 1 over, I'll go ahead and distribute now like Kenny did, 1 over x squared plus x equals 3. Now what? I'm gonna like basically cross multiply. So this times this is just 1, and this times this is 3x squared plus 3x. Okay? And then what do I have to do to solve that? That is equal to 0 because it is a quadratic. And then where do we go from there? Quadratic formula. Okay? Or you can do that on your calculator.
I don't know how to do it.
How to do what? How to solve that?
No, the function.
Function thing? What function thing? What function thing? Like the equation solver or just the...
I don't know, there's like a button you can push where A, B, and C pop up, you know?
Oh, use the program?
They had that quadratic.
Right, did we do that together last year?
Yeah.
Yeah, I was,
Oh, yeah, we're being cool.
No, it's
Not
not.
using anything on our calculators.
What'd you say, Jeff?
They're just kind of basic functions.
Last year? Yeah.
There's no assignment.
Okay, put it on that stack behind you then. Yeah, so last year we wrote a formula that does the quadratic formula. So in this one, what was A? What was A?
3,
3. What was B?
3,
And C was?
-1.
-1. And so our two answers for X are those crazy things right there. Okay? If you don't have that program on your calculator, we can very easily connect to them and trade it. Maybe we'll do that. We're going to have a little extra time here at the end. Okay, and then the last one, solve for t this time. So how do you want to start that? Square. So square both sides. So 2 squared is 4. This stuff squared is the square root just goes away, right? So if I FOIL this, what do you get?
1 plus 2t plus 2t.
And if I FOIL this, what do I get?
1 minus 4t plus 4t.
All right, so if I combine my like terms, t squared and 4t squared is 5t squared. 2t, take away 4t is negative 2t. 1 plus 1 is 2. Equals 4. Swing the 4 over there to the other side. And then how do we do that? The button on your calculator. 5, -2, and -2. 5, -2, -2. And there you go. Okay? So much quicker. Okay, do you guys have any messages for Elina before we shut down here? No? What? Hi. Hope you had fun on your job, Shadow.
Elina, you thought he wasn't going to give us homework. He did.
That just happened.